Okay, in this particular video, I'm going to address some of the common mistakes that student makes in kinematics graph questions. Okay, so first of all, for the content, one of the common mistakes that students make is when they are tasked to find the gradient of a graph. This is especially a case when the gradient doesn't start from the origin, or when the gradient is a gradient at a point. Okay, another possibility of a mistake is when they were tasked to find the area under the graph. Sometimes they might find an area that is lesser than what is required, and another possibility is when the graph is negative. So without further ado, I'm going to go into the first case, which is the gradient of the graph. I need to first go to some basic information, and this basic information is important. You need to know this before we start. Okay, so one of the basic information is that the distance time graph, alright, if you want to find the gradient, is to find the speed. Okay, so that means that in the distance time graph, if you find the gradient, is to find the speed, and in the speed time graph, if you want to find the gradient, it is to find the acceleration. Similarly, if it is a displacement time graph, you will find the velocity in the displacement time graph. If it's a velocity time graph, you'll find the acceleration as well. Then, conversely speaking, if you are finding the area in the graph, only the speed time graph will have is to find the distance traveled, or velocity time graph is a displacement traveled. Alright, so this information you need to know by heart before we start. Okay. So first of all, let's look at this question. Now, this question, there is a particular line that doesn't start from the origin, and I'm referring to this line. If you extrapolate it downwards, you will not cut the origin. So what's wrong? For example, if they ask you to find the velocity of the object from t equal 20 to 30 seconds, some of the common mistake that students make is, okay, let me just use my pointer. Okay, is that they assume that, okay, the distance, they usually like to find the last point on the line as the point where they draw the rise over the run. Then they'll use this as their rise, and then they'll use this as their run. Okay, what's wrong with using this way? Okay, if you use this way, you will realize that actually you are trying to find the gradient of a line that starts from the origin and goes straight to here, right? Because this is a straight line, so the rise over the run will be the gradient of this straight line. But you're not finding this gradient of this straight line. You want to find this particular line. So obviously this is the wrong method. Okay, this is the wrong method. You cannot just use a point. So what is a correct method? So whenever you have a line that is going in an opposite direction, or there is a disjoint between the two gradients, what you should do is to look for the triangle that forms this line. Okay, so this line starts from here to here. So this line actually forms a triangle, and this line is actually the hypotenuse. So what do I mean by this? If you draw it, one line across to this point, and then you draw another line up here, you get your triangle. So once you identify the triangle, okay, you know that you have found your gradient, because this will be your run and this will be your rise. Okay, so if you keep using this method, that means to identify the triangle. Okay, let me just write down here somewhere. Identify the triangle. Okay, if you use this method, you will be very safe. Okay, in this case, let's find the velocity. So the rise will be 50 minus 20, which is 30, and the run will be 10. So you get 3 meters per second. Alright, so in this case, you will definitely be correct. Okay, so this is the first method that I want to show you, which is to identify the triangle. Now let's look at, let's check for understanding. Now, if I want you to find the acceleration in a speed time graph from the 10th to 30th second, so how do you find? So once again, from 10 to 30th second is this region. So if this is this region, then obviously the triangle will be here and here. So you have just found your rise and run. Your rise will be 1 and your run will be 20. Okay, so what is the acceleration? The acceleration A will be 1 over 20. So what is 1 over 20? Zero 0.05 meter per second square, right? So that's a very safe way to find the acceleration using finding the triangle or the gradient. So let's go to the second issue. Now look at this question. Okay, what is the difference between these two questions? What is the speed of the object between 0 to 10 second journey, and the other one, what's the speed of the object at the 5 second journey? Actually, the answer is they are the same because the gradient is the same throughout. Okay, but unfortunately, when the question is posed in the second way, which is this one, some student will just say, I don't know how to do because it's in the middle of nowhere, so I cannot find the rise over the run. I'm comfortable with using the whole triangle. But actually, the truth is you can use the whole triangle and find the gradient, and you will still have the same answer as the gradient at this point. Okay? So let's look at this example. If they ask you to find the speed of the object at the 5th second, right, you simply have to identify first the 5th second is here, and then you realize that actually this whole line is a straight line. So because it is a straight line, you can actually use the whole line, okay, and then you use the same method as what I mentioned just now. Find the rise over the run. Sorry, again, it's very crooked. So the rise is going to be 10 and the run is going to be 4. So the speed will be equal to 4 over 10, which is 0.4 meter per second. Alright, so similarly, if you want to find on the 15th second, which is somewhere here, which is even harder to understand, you can use a triangle here. You see, this will be your run and this will be your rise, but you realize that the rise is now falling. So if the rise is falling, it's actually negative. Okay, but let's assume that because they are asking for speed, so we just take it as by its magnitude. So the run is going to be 10 and the fall is going to be 5. Okay, so the speed in this case will be 5 divided by 10, which is 0.5 meter per second. So there's nothing difficult about this. It's just finding the triangle, and any point along this line can be represented by the gradient of the whole triangle. Okay, so let's move on to the next issue. The next issue is the area under the graph issue. A lot of students, if they are asked to find the distance traveled by an object, for example in this kind of special graph, okay, so what is the common mistake? Common mistake is that students might assume that this is the only area that they need to find, alright, which is wrong, because the area has to be bounded with the x-axis and the graph. So you need to find all the way to here. Alright, so how do we do? Okay, you cannot use trapezium rule anymore, so you need to either divide this into two parts, here and here. If you use here and here, you will realize that actually there's a trapezium here and then there is a triangle here. So the distance traveled d will be equal to half. Okay, let's use trapezium rule. 15 plus 5 times 4 plus, now this one will be 6 times 15. Alright, so I won't work out the answer. So I'm just trying to show you that this is the correct method to do. Now, what is another possible mistake? Another possible mistake is when you have a velocity time graph that goes to the negative of the y-axis. Okay, so let's say I want you to comment about the displacement covered by the object in the first 5 seconds and the last 5 seconds of the journey. So how will you do it? Okay, some of the common mistake is that some students might think that this is the first 5 second area covered. Maybe let me redraw again. Maybe they may think that this is the first 5 seconds. Alright, so this is again wrong, because you need to know that it is bounded by the x-axis and the line. So it's bounded by the x-axis and the line. So this is the first area. Okay, the other common mistake is that they also know that this is the second area, but they think that this is actually positive. Alright, which is wrong. Okay, so this has to be negative and this has to be positive. Why? Okay, let me just explain with the next slide. So what happened is that the velocity time graph actually represents an emotion in real life. So in the first journey from here to here, the velocity is positive. So when the velocity is positive, that means that it's moving forward. But when it moved into this region, the velocity is negative. So that means that it's moving backwards. Alright, so that means that this is the time that is moving backwards, and this is the time that's moving forward. Alright, so because of that, you need to know that if you are moving backwards, okay, if I draw the graph, okay, the object is actually behaving something like that. It starts from this point, it moves to a certain point forward. Let's use F to represent forward. Then when it reaches a maximum point, it go backwards. Okay, B. We do not know how much is traveled, but if you look at it represent in the real life situation, you know that obviously this region here, okay, and this region here has to have a different sign. This region is positive because it's moving forward, and this region is negative, because it's moving backward. Alright, sorry, all the too much information here. So how do you solve it? You find the area here and the area here. So the displacement, first 5 seconds, the displacement is going to be half times 5 times 20. So you get 50 meters. Now for the last 5 seconds, okay, you'll have to put a negative sign because it's moving backwards. Okay, again, this is 5. So you get minus 50 meters. So if you want to find the total displacement after the whole journey, is obviously 50 minus 50, which gives you 0. Alright, so I hope that this information is helpful for you to understand the misconception that some students have. If there are still some misconceptions, you can write some comments, and I will try to review it in a future video. Okay, thank you and have a nice day.